Chapter 5, Section 5, Definition and Uses of Molarity. Molarity is the most often used chemical measure of concentration, and you're going to use molarity to solve a bunch of problems. Okay, so solution is a homogeneous mixture of two or more substances. The component present in the greatest amount is the solvent. Generally, we're going to see this as DH2O or deionized water. If you go on and take organic chemistry, you might have a different solvent like hexane or hexene or any number of different things. Substance or substances dissolved in that solvent are solutes. So these are the two things. Whenever we say two or more substances, we've got a solvent and a solute. There might be more solutes than solvents, though. There might be 3 different solutes or something like that. Concentration expresses the quantity of a solute in a given quantity of solvent or solution. Solutions are relatively large. Solutions with a relatively large amount of solute per volume are said to be concentrated. Solutions with a relatively small amount of solute per volume of solvent are said to be dilute. And one way you could kind of visualize that is we'll just use this as our container. Here's the solution, and red dots are going to be my solute.
We were just talking about that actually.
So we got all these dots indicating I got the solute compared to this one over here, where we've got approximately the same volume, but we've only got 1, 2, 3 red dots. Okay, so this would be dilute.
I've done it a couple times,
and this would be concentrated.
So
these red dots, though, we're going to go into what those different things are, and we're going to do lots of practice problems. Molarity is a type of concentration defined as the number of moles of a substance or of a solute per liter of solution. My phone got interrupted, I just got a phone call, but it was a solicitor, so I'm not going to go on with that. Okay, so molarity is a type of concentration where we're looking at moles of our solute per liter of solution. So the unit of molarity is molar. We're going to use a capital M, the big M for that. So 0.50 big M NaCl means there are 0.5 moles of NaCl in 1 liter of a solution. So that means we have 0.5 moles per 1 liter. Okay, so that gives us 0.5 molar. Okay, so that's kind of a ratio, the ratio of moles of our solute per liter of our solution. Okay, so here's an example. Calculate the molarity of a solution containing 7.5 moles of formaldehyde, 7.5 moles, okay, CH2O, which is formaldehyde, in enough water to make 1.5 liters of a solution. Okay, so this gives us right here moles of solute per liter of solution. Notice, what's a little bit of a curveball here is that it's not exactly 1 liter, it's instead 1.5 liters. Does that matter though? It really doesn't. All that we need to do is say 7.5 divided by 1.5 liters, and we're going to get our concentration in terms of moles per liters of solution. So 7.5 divided by 1.5 gives me 5.0 molar. Okay, so there is my solution right there. It's a 5 molar solution. All right, now to continue this, molarity can also be defined as the number of millimoles, little m, mole, of solute per milliliter of solution. So little m, capital L. Okay, so now one thing that I want you to think about is this is the same thing as is defined right here, the same thing as moles per liter. Heck, if you scribble out these little m's, well, it's moles per liter. Okay, so quantities of solute in solution are given in units other than moles and liters. Sometimes you'll see millimoles and milliliters. They can be converted to the appropriate units to calculate your molarity. We'll see that demonstrated here. Calculate the molarity of a 60 milliliters of solution. Okay, so here we've got our volume, which I'm going to go ahead and write that on the bottom, 60.0 ml, containing 1.25 millimole. I didn't have to do anything to change these units. Okay, So I'm going to divide 1.25. 1.25 divided by 60 equals 0.0208. Now what are my units? Well, these milli are going to cancel out, so I'm left with capital M, a molar solution. Now if we look at this question right here, it's a little bit tricky. Calculate the molarity of 50 milliliters of a solution containing 7.5 grams of methanol. What do we do with that? Well, you guys know how to do this, and I know you know how to do this. The first thing that you need to do is take this mass, and we need to convert it to moles of CH4O, or of methanol. Okay, so 7.50 grams of CH4O. I know that the molar mass of methanol is 32.04 grams CH4O.
Okay,
That's
well,
1 mole.
I pulled it up, but maybe.
Now what I'm going to be able to do with this is I'm going to solve for the number of moles of this. So 7.5 divided by 32.04 gives me 0.2341 moles of CH4O. Okay, and I'm going to divide that by, well, heck, 50 milliliters. What do I do? Well, I tell you what you do. You convert that 50 milliliters into liters. Okay, now there are 1,000 milliliters in 1 liter. So we can do a dimensional analysis. I'm going to do it at the bottom here. 50, 1,000 is 1 liter. So 50 divided by 1,000 equals 0.0500 liters. So that's my volume in liters. Plug that in there. 0.0500 liters. Moles per liter, I've got that. So 0.2341 divided by 0.05. 4.68 molar. It's a 4.68 molar solution. And there you have it. So another thing that we can do is this sort of calculation. What we want to do is calculate the number of millimoles of alpha alcohol C2H6O in 29.21 milliliters of a 6.013 molar solution. Okay. Now, if you remember what we saw earlier, we saw that moles per liter was the same as millimole per milliliter. Okay. So this is all equal to, that's all equal to our capital M. Now what I'm going to do is I'm going to take my volume, 29.21 milliliters, and I'm going to set up a dimensional analysis where I take this number, the 6.013, and throw it through here. And I'm going to say 6.013 millimole per 1 milliliter. Now, I did a conversion without even really having to do a conversion. I converted moles per liter into millimoles per milliliter. Now that I've done that, what I can do is take this 29.21 and multiply it by 6.013. My end units, millimoles. My question's end units, millimoles. So 29.21 times 6.013 is equal to 175.6 millimole of C2H6O. This next item pertains to concentration. This is dilution. And I'll tell you this, dilution is the solution to pollution, but also dilution is the process of adding more solvent to decrease the concentration of a solute in a solution. So you could see that as, or you can kind of visualize that as, if you have a solution that has, again, these red dots in it, let's say that that's sodium chloride floating around in there, and you're like, if I drink this, Mr. Yuck Face. But then if you add DH2O to it, now all of a sudden you've put it in a different container, you've increased the volume of deionized water, you've added more water to it, now all of a sudden these dots Well, there are fewer of them per volume unit. And so then you might drink it and it might not taste quite so bad. So use the definition of molarity to calculate the concentration of a solution prepared by diluting a more concentrated solution. So to do this sort of problem, what we do is this sort of problem is to calculate the final concentration of NaCl after 1.25 liters of 0.5 molar
I think that's a
NaCl
good point too.
is
Like, they may
diluted
not
to
realize that we're
2.5
waiting
liters.
for
Okay,
them
let's
to move
visualize
on with
that.
our
So
day
what we
or
start out
something,
with
you know,
is a solution
that would impact
that is
me as a person. I wouldn't want
1.25
to be waiting.
liters. Okay, so I'm going to go ahead and make a marking. That's 1.25 liters. There's our solution. We've got these dots indicating our 0.5 molar solution. Now what we're going to do is we're going to add DH2O, that's our solvent. And now, deionized water, have we added any more NaCl? Think about that, deionized, no ions present, okay? So no ions present here, so then what we're going to do is we're going to increase the solution volume to 2.50 liters. These dots are still there and everything like that. Has the number, or has the concentration of NaCl changed? Yes, it has, because our volume has increased. Okay, so the question is the prompt is calculate the final concentration of NaCl after 1.25 liters of 0.5 molar NaCl is diluted to 2.5 liters and diluted with the addition, or by the addition of 2.50 liters. Okay, so essentially what this is getting at is an equation that's fairly simple. C1 V1 equals C2 V2. Concentration times volume is equal to concentration times volume. Now, where do these numbers come from? Well, this C1, this is your initial concentration. V1, that's your initial volume. Okay, C2 is your final concentration. V2 is your final volume. Okay, now in this question right here, specifically A, we've got some of this information. We have our initial concentration, 0.50 molar. Okay, we have our initial volume, 1.25 liters. That is equal to our final concentration, which we don't know. So I'm going to leave that as C2, and V2 is our final volume, which is 2.50 liters. Okay, so what we're going to do is we're going to solve for C2. So 0.5 times 1.25 equals 0.625 divided by 2.50. And that's going to get a concentration of 0.25 molar. Okay, so our new concentration is 0.25 molar. It's half of what it originally was. But what happened to our volume? Well, our volume went from 1.25 liters and it doubled. So the addition of 1.25 liters of water to give us a total volume of 2.50 liters. Okay, so now question B. And diluted by the addition of 2.50 liters. Okay, so now what we have is kind of a continuation of that problem. We have 0.25 molar times 2.50 liters. And I'm getting this from kind of our initial concentration and our initial volume in part B is our final concentration and our final volume from part A. Now, when we add 2.50 liters to 2.50 liters, what happens? Well, we've doubled our volume. We've gone all the way up to 5.00 liters. So now what I'm going to do is I'm going to plug this info in. 0.25 times 2.5 divided by 5. And that gives me a concentration, C2, which is equal to 0.125. molar. Okay. Well, this wraps up concentration. There are some more problems like this, or there are some more involved problems with this, and we'll tackle those in the remainder of this chapter. But I hope this was helpful, and I will see you in 5-6. All right, have a good one.